Hey guys, it's Gilsdorf. Disregard the scratching out of the section number, but this section is just going to be about conservation of matter and balancing equations. So this is all fundamentally focused on the idea of the law of conservation of matter or law of conservation of mass. They mean essentially the same thing, but in all chemical reactions, matter needs to be conserved. So you cannot create matter, you cannot destroy matter, you can only rearrange it. Now, some of you are going to be like, well, I'm pretty sure that E equals mc squared says something about light being created from matter or matter being created from light. Yes, there are some instances in physics where matter and light can kind of cross over a little bit, and you can lose some mass, but those are going to be rare and they're not chemical reactions. So we're focused on the conservation of matter and mass in chemical reactions. So in a chemical reaction, what goes in must come out. And I always use the idea of a daycare. If I drop off 2 kids, then at the end of the day, well, I don't want to drop off 2 kids because I don't even like kids. I don't have kids. I don't want kids. I don't want to. I mean, if I drop off 2 kids and they give me none at the end of the day, that's a blessing. But most people would be very upset and they would want both of their children back. So the whole idea is whatever goes into the reaction needs to come back out. And so we show that by balancing the equation numerically. To balance the equation, we start by counting up how many of each we have, or each atom we have on each side. So coefficients and subscripts and parentheses are going to be the methods for how we deal with those numbers. We've already done these a little bit, so you know that if something has a subscript on it, it means that there are that many of the thing that it is directly behind. So in water, there are 2 hydrogens and 1 oxygen. Yes, let's reiterate that. It should be 1 oxygen and 2 hydrogens. How come some of y'all on your Unit 4 exam trying to put 1 hydrogen with 2 oxygens? What on earth? Okay, so 2 hydrogens and an oxygen. The 2 refers to, or a subscript refers to the letter directly in front of it. Coefficient refers to the entire molecule, and parentheses refers to just what's in the parentheses. So if something has a subscript directly behind it, it means you have that many of that substance. So water, we just said, has 2 hydrogens and 1 oxygen. In ammonium nitrate, we have ultimately 2 nitrogens. There's 1 here and 1 there. I'm going to switch my color so it stands out a little bit. And then we have 4 hydrogens and 3 oxygens. Parentheses tell us to distribute anything outside the parentheses to everything inside the parentheses. So in this case, calcium is outside the parentheses. There's only 1. There are 2 copies of nitrate, and a nitrate, remember, is a nitrogen. Well, this isn't perfect, but a nitrogen with 3 oxygens attached to it. And so when I have 2 copies of that, it is literally 2 copies of that. So I would have 2 nitrogens and 6 oxygens. Same thing holds true at the bottom. Subscripts, of course, are important for general elements, and anything outside parentheses distributes to everything inside of it. A coefficient basically means that you are copying the entire molecule. So the entire formula gets multiplied by the coefficient. So what I generally do is look at subscripts, look at parentheses, and then do the final multiplication based on whatever the coefficient is. Well, that coefficient is going to be important because that's the location where we can actually do some work in balancing the equation. I can't change this because the ratio here is that I need 1 magnesium for every 2 acetates because they have charges. C2H3O2 -1. I need 2 acetates for every 1 magnesium. I have to keep that ratio down. But if I needed more magnesiums and more acetates, I could multiply the entire molecule by a number and distribute it accordingly. So on your practice sheet, go ahead and do practice problems 1 through 6. If you've already done them, awesome. Then just check over it, see how you've done, make sure that what we've done so far makes sense, and then we can move on. So a balanced equation is it is a recipe. It does 2 things. It tells you what the reactants are and how much of each you need, okay? So it's telling you what the end products are and how much are going to be produced, just like a recipe. You know when you start a recipe how much you need and what's going to be produced. So that's going to be a balanced equation. We get it to equal each other on either side, so we have the full balanced recipe. Basic rules here. Number 1, only add coefficients, never subscripts, because when you change the subscript, you've changed the ratio. And we learned in ionic bonding that Ratios are mandatory. They are required and they are constant. You can't change a ratio. So don't change your subscripts, only multiply the molecule a couple times. Never try to balance the number of oxygens first, unless you have to, but usually oxygen gets weird because it has a -2 charge, so it's just all over the place. And then coefficients must be whole numbers. Let's practice. Okay, so looking at an equation, you get the equation, and what you're immediately asked to do is separate the reactants from the products. The reactants are going to be on the left side of the arrow, the products are going to be on the right. So then you count up how many of each atom you have. We have 1 carbon on the left, 4 hydrogens, 2 oxygens, 1 carbon on the right, 2 hydrogens, 3 oxygens, and so we have an imbalance. The carbons look balanced, the hydrogens are not balanced, the oxygens are not balanced. Well, I'm going to try to balance the hydrogen. Ignoring the equation, okay, so if I were to actually cover up the equation and look just at the bottom, okay? If I'm looking just here, I see the carbons are balanced, the hydrogen on the left is 4, on the right is 2. So I'm going to need to multiply wherever the hydrogen on the right is, I need to multiply that by 2. So let's go back to our equation. Let's slide that out of the way. Finding hydrogen on the right, I see that I need to multiply it by 2. Okay, that's going to distribute not only to the hydrogen now, but to the oxygen. So that has changed my hydrogens to 4. Carbons are currently balanced. Hydrogens are now balanced. Oxygen, I now have 2 right here, and I have distributed this other 2, so I have 2 on the other side as well, so I have 4. Now, on the left-hand side, no, get away. On the left-hand side, I have 2. Multiply that by 2, add a 2, and I now have 4. That means everyone is satisfied. So here, it is basically 1 to 2 to 1 to 2. So now we're not just looking at chemical formula ratios, we're looking at equation ratios and realizing that the entire equation is a ratio. For methane to oxygen, I need twice as much oxygen as I need methane, or CH4, to react, and I'm going to produce carbon dioxide and twice as much water. So that is the ratio of a balanced equation. Looking at this last one, I'm going to run through it the way you probably would run through it, and then we might see that we need to change some things, and that's cool. So, looking at aluminum, I have 2 on the left, 1 on the right, so I need to multiply this one by 2 to change this to 2, all right? Then looking at my oxygens, I have 3 and 2. Ooh. I need to go to the least common multiple between those two, okay? So just like when we were doing our ionic compounds, I got to do the same thing here and go to the least common multiple. So this one needs to be multiplied by 3 to make it 6. This one needs to be multiplied by 2 to make it 6. So I'm going to put a 2 out there. Notice where I put that 2. I can't put it in the equation for aluminum oxide. I have to put it in front, okay? I can't just be changing the ratio and say, oh, let me just put a 6 or blah, blah, blah. No, that's not how it works, okay? So then I fix my oxygen on the right. That means that this 2 distributes to aluminum, which is now 4, and distributes to oxygen, which is now 6. Ugh. Now aluminum's messed up. But guess what? Nobody freaking cares. Because all I need to do is go in here and erase it. And change it to a 4. Okay? Because this is all just guess and check. I'm just guessing and checking. That's all I'm doing. So as long as you're guessing and checking repeatedly, you're on the right track. Okay? So what I'd like for you to do is run through the rest of the practice problems on your paper. I would try to avoid, for right now, if you're feeling scared, I think questions 7 and questions 9. The question that starts with H2O2 and the question that starts with glucose, or C6H12O6, skip those 2 for right now and then come back to those when you're done, just because those are a little bit more challenging, so they may break your confidence a little bit if you're not feeling it. Okay? So hopefully at this point you may need to do some of this math, but eventually we want to get to the point where we don't have to be doing that math anymore and we can just do it in our head. Okay? All right, but don't worry, because I have plenty of practice. See you guys next time.